Alright, we are going to look through the data sheets for Lab 9, which is biomechanics. You should be looking at page 74 in your lab manual. If you look at that, under procedures, we know that Sam's weight in kilograms is 77.27 kilos or kilograms. And we've also been given his times for his 40-meter sprint. So if you look at number 5, we have his 10-meter, 20-meter, 30-meter, and 40-meter interval times. So you will need those when you do the calculations on the next page. Also, look at number 7. You're going to need to do graphs of the following: velocity versus time, momentum versus time, kinetic energy versus time, and acceleration versus time. And we're going to do all those calculations on pages 75 and 76. You're going to take those and put them into graphs of those, and you're going to turn those in to me by scanning them in and emailing them to me. Alright, look at page 75. What I did here is I went through for each V1, M1, KE1, and acceleration 1, I did the calculation so you have something to look at that you can base your calculations off of. So looking at velocity 1, the equation there is 10 meters divided by time 1 minus time 0. So in this case, time 0 is 0, time 1 is 1.5 seconds. So we just take 10 meters, divide that by 1.5 seconds, and the initial velocity for the first 10-meter interval of Sam's sprint is 6.67 meters per second. And then you'll go on and do the rest of those. So V2, V3, V4, and the total for his 40-meter sprint. So you'll do all those calculations. Next one is average momentum. Momentum, like we talked about, is mass times velocity. So for M1, we've calculated V1, which is 6.67 meters per second. We know Sam's mass, which is 77.27 kilos. So we just multiply those two together. Very simple calculation. That comes out to be 515.39 kilogram meters per second. Okay, so moving on to average kinetic energy for C. Kinetic energy equals 1/2 mass times velocity squared. If you look at that data sheet, you'll see that I just had 0.5 times 77.27 kilos times 6.67 meters per second squared. Following that through, you have 38.64 kilos times 44.49 meters per second squared equals 1719.1 joules, or 1719.1 joules. So kinetic energy is going to be a large number. Momentum is going to be a large number. So you'll need to go through and do the rest of those kinetic energy calculations as well. Turn over to page 76. Looking at page 76, we have acceleration. Acceleration 1. V1 minus V0. Obviously, before Sam started moving at all, he had a 0 velocity. When he hit the 10-meter mark, his velocity was 6.67 meters per second. And his time before he started was 0. And the time it took him to cover the first 10 meters was 1.5 seconds. So his change in velocity is 6.67 meters per second. Change in time is 1.5 seconds. Divide those, and you come out with 4.45 meters per second squared. So that's his acceleration for the first 10 meters of that 40-meter sprint. You'll go on and calculate the rest of the accelerations. One thing to remember with acceleration, if Sam's velocity from during one interval slows down from the previous, you're going to come out with a negative acceleration, meaning that Sam was slowing down. That is okay to have a negative acceleration if you calculate that. All right, get those done. Get those into me, including the graphs. So I need to have all the data sheets, your calculations written out, and the graphs that you do. Also, you're going to go under assignments and answer the questions for Lab 9.